point in running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
Questions. Research.
technology.
Unbelievable.
Without further ado,
This is The Naked Scientists. Hello, welcome to The Naked Scientists, the programme that brings you the latest breakthroughs in science, technology and medicine. And this week we're drilling down into the fracking debacle. Party politics get pushed aside so the science can take centre stage. What is fracking? Will it help or hinder our energy headache? And at what environmental cost?
The Naked Scientists podcast is powered by ukfast.co.uk.
Welcome to this week's special feature on fracking with me, James Titko, and Chris Smith. As mentioned, we're going to try and get to the bottom of one of the most divisive topics dominating the discourse here in the UK and abroad at the moment.
Promised on entering Downing Street to act. Let's get them removed.
No, not Prime Minister Liz Truss per se, but the cause being championed by the people she was interrupted by at the Conservative Party conference. They were fracking activists. Hydraulic fracturing, or fracking, is an industrial process that's undertaken to access pockets of gas locked inside rock formations underground. There's reputedly a very large reserve of this fossil fuel resource that can be recovered this way, so it's seen by its proponents as a vital part of the solution to the energy crisis currently rampaging across the world, particularly as ongoing tensions with Russia mean gas supply security looks very uncertain and definitely remains very expensive.
Critics, on the other hand, say that lifting the fracking ban is a case of robbing Peter to pay Paul. While it might defer energy concerns, although to what extent is also up for debate, it is in direct conflict with another significant and pressing issue, climate change. It may also have onward environmental impacts, including groundwater contamination and seismic activity, in other words, earthquakes.
This led to some heated exchanges in the House of Commons recently between the Energy Secretary and his shadow counterpart.
And I'm glad to be able to announce that the moratorium on extraction of shale gas is being lifted. It is important that we use all available sources of fuel within this country. It is more environmentally friendly to use our own sources of fuel rather than to extract them from other countries and transport them here at great cost, both financially and in terms of carbon. And we need to revisit the seismic limits to ensure that shale gas extraction can be done in an effective and efficient way.
They are lifting the ban, but they can't supply the evidence. And the British Geological Survey published today certainly doesn't do it. So, in the absence of the evidence, his approach is to change the safety limits. You can't escape a fossil fuels crisis by doubling down on fossil fuels.
We know that shale gas is safe. It's safe in the United States and has been one of the biggest contributors to the decline in carbon emissions in the United States of any activity that has gone on in that country. We know that seismic activity of 2.5 and below on the Richter scale takes place millions of times a year across the world. Bringing on this supply will bring us cheaper energy, which we need.
Jacob Rees-Mogg and Ed Miliband. So today we're going to remove the party politics from the equation and we're going to see what the science has to say. I suppose you could say we're sorting fact from fiction, and if we end up with earthquakes, then friction too.
Before the show this week, we asked our Twitter followers what their gut reaction was to whether fracking had their support. 68% said no, 20% said yes, and 12% were unsure. It'll be interesting to see if by the end of today's show, anyone might have changed their mind.
Well, to kick us off, I'd like to introduce Andy Woods, who is a scientist who studies how fluids behave at the University of Cambridge. He's therefore just the man to explain to us how fracking works and what it entails. Welcome to the programme, Andy. What actually is shale gas? Is it the same stuff that we would get from under the North Sea, to all intents and purposes?
So shale gas is essentially a large part of it's going to be methane, but it's different from the gas that comes from some of the other reservoirs because it's trapped in shale, and shale is very fine-grained sedimentary material with grains of size about 10 microns, and the very small pores between those grains is where the shale gas is host, and then there's also some gas absorbed on the surfaces, and so there's organic matter inside those shale deposits, which ultimately is the origin of that gas. But because these rocks are so fine-grained, the gas can actually be trapped inside the rock and doesn't flow in normal situations. It'll have extremely slow flow rates.
The reason that we don't have to frack under the North Sea, for example, presumably the geology there means you've got big pockets of gas all in communication, whereas when it's in these tiny pores in the rocks, you need to smash the rocks up a bit in order to make those little pockets of gas join up to make big ones.
So I think fracking as a process occurs in lots of different situations, but with the shale, the gas is essentially locked into those small pores in the shale, and so what you do is you drill a well down to the shale formation and then pump up a mixture of water and sand and some chemicals and seal off the rest of the well, so that mixture can actually open up fractures in that shale, and the water carries the small sand particles with it, and they end up propping open these fractures so that you've essentially opened up and provided a flow path from the rock back into the well to allow that gas to flow.
How deep underground are we talking?
Well, this will vary depending on the formation, but we're looking at of order 1-2 kilometres below the surface.
And how do scientists know it's there?
If you look at the shale deposits, if you look at the geologic history of the different basins and different deposits, there's hints from that there will be gas present in different deposits. But if you actually produce a sample of the shale and find organic matter in it, and that's been through an appropriate process of being buried in the earth and coming back up again, you'd expect that to have some of that to have produced gas.
And I follow what you say about the fact that you break open the rocks and then prop open the gaps with the sand grains. How far can that effect go then? I mean, how far can you reach with one particular shaft, one drill shaft?
So you may actually drill a well vertically down, and then it may run horizontally through the formation, and then you'd prop open different parts of that, selectively increasing the pressure of the hydraulic fluid. So essentially you're providing surface area for the gas near that surface area to flow into the well.
So does this mean then to get an appreciable amount of gas out, you've got to drill lots of holes, or can we actually recover a reasonable amount of gas from just one drill site and then you just keep it open for a while?
So the gas that will flow into the fractures that you're creating that are connected to the well is only going to come from a very small distance away from that fracture, maybe of order a few centimetres typically.
The thing that people are concerned about, really, there are two aspects, aren't there? There's what happens to the ground. Does it destabilise it? Does it cause earthquakes? That's what Jacob Rees-Mogg was saying. We should get used to a few more earthquakes, and also whether or not the chemicals that go down the mud and the water and so on, whether they go down and stay down or whether they go elsewhere. So what do we know first of all about the earthquake side of things?
So we do know there's earthquakes that can happen. Being able to predict exactly how many earthquakes and the distribution of earthquakes is much more challenging because it depends on having a detailed understanding of the fault distribution, the stress state of the rocks where you're injecting the fluids.
And the question of what goes down, does it stay down or do those liquids move?
So the liquids are typically you try and recover some of those liquids, because if you've opened up this flow path to actually allow the gas to flow back out up the well, if that fracture when you produced it, it's full of the water you've injected with the sand and the chemicals, and that's obviously going to provide some resistance to having gas coming back out through that flow path. So normally you try and back produce some of that and bring it back to the surface and then dispose of that water. But some of the water may, because of effects of surface tension and a process called imbibition, some of that water may flow into other parts of the formation or may be absorbed into some of the clay materials.
We'll look more at these environmental questions as we go on with the programme. But Andy, thank you very much for giving us an introduction to it. That's Andy Woods. He is from the University of Cambridge. It's The Naked Scientist with me, Chris Smith, and also with James Titko. We're looking at the science of fracking. Now, this is a process and a procedure that's been blocked for many years on environmental grounds in some places, but now it's very much back on the agenda and back on the table in a number of countries because of what's going on with the energy and the cost of living crisis with which the world is grappling.
So, having familiarised ourselves with the process itself, let's switch our focus to some of the economic arguments for and against shale gas extraction. Cambridge-based Michael Grubb is a professor of energy and climate change at University College London. Thanks for coming in, Michael. We're talking about this because the moratorium on fracking has been lifted. Can you tell us a bit about why fracking was banned in the first place?
Yes, I think it's useful to look back and recognise that there was a huge wave of enthusiasm about fracking, at least in the industry, about a decade ago. There'd been pretty much a technology revolution in the US, and there was lots of hype about Europe was going to get on the act. Actually, most of that ended in disappointment. Across much of Europe, including the UK, there were some pockets of potential fracking, but most of the industry concluded it wasn't going to be very much, it wouldn't be very cheap, and it really wasn't worth the risk. So I think the general environment was actually this is not remotely what it was hyped up to be, and there were problems and risks and political opposition, and the government simply decided it would be simpler to ban it.
So just to clarify, you've mentioned how, particularly in the United States, fracking's enjoyed some success. The main reasons that we couldn't replicate that success in the UK, that's to do with us not knowing exactly how much shale gas is under the surface of the UK.
The US has a vast land surface compared with the UK, and a lot of it is much less population. That's one thing. There's still very much the US industry is concentrated on some particularly good resources. Nothing in the geological mapping suggested we had anything that was going to be that good, big, cheap, or easy to access. And land in Europe as a whole tends to be a lot more expensive than in the US. One final factor is the legal regime was different. So people who had land in the US, they owned the gas underneath. It gave them a strong incentive to put up with disruption if they got the money. And that's not generally the situation here.
So I suppose what's different now, could the lifting of the moratorium, this is the big question, alleviate the surge in energy prices being felt here in the UK at the moment?
Well, I mean, I think there's four challenges, frankly, that shale is going to face. There's timescale, there's cost, there's markets, and there's risks. The timescale is determined partly you have to drill dozens of holes to really know what's there in detail and to establish what you can actually inject, how much it's going to take, etc., etc. Then the cost of getting at it. Obviously, it is a lot easier to drill a hole down into a pure reservoir of gas and it comes up in a pipe than it is to go through the processes that's just been described. That's probably makes it more expensive than normal gas resources, but it could still be economic at these gas prices for sure. But bear in mind the timescale implied in there is it's going to take several years to get substantial supplies. The third thing is markets, because these are global industries. Would we be saying to companies, sure, go ahead and frack and sell it on the international markets? Well, the volume that we would sell would make virtually no difference to the global price, or therefore to our price, unless we actually kind of forced companies to sell it to Britain first at a less economic, less attractive price. And then finally, there are the environmental risks, and whether something goes wrong, that basically does create a bit of a backlash. And so I'm not sure the industry is that keen to jump in here. For the most part, some companies, a few specialist companies are, that have put all their eggs in that basket.
So it looks like the odds are really heavily stacked against fracking. I just wonder if something like, for example, today, the objective of this programme has been to sort of remove the politics from this quite contentious topic. But the reason we're having this discussion is because politically it's very topical. And I wonder if something like the National Grid coming out today and saying that winter power cuts might be a worst case scenario in the coming months, whether that might mean that the government sees fit and it gives the companies the the assurances to make them start drilling. Do you see that as a possibility, that the politics has a role over the economics?
Well, I think for whatever reasons, clearly the government is signalling that it's in favour of fracking. It wants it to start up again. It's pushing it quite hard. There's obviously an instinctive appeal about trying to extract your own energy resources. I mean, it will have consequences internationally as well, and implications. I think it's actually, I must admit, a little ironic hearing the news in the last couple of days about lights might go out because of this. I actually, for 3 years, chaired the government committee on electricity security, called Expert Committee on EMR, and raised this question about, we're assuming that because we've got enough gas plants, therefore our electricity will be secure. Isn't that an assumption we should look at? And I was pretty robustly told, no, this is an electricity committee. We've got enough diversity in gas. You needn't worry about gas supply. So, Michael, stay in the box of electricity. But, energy markets have always had a capacity to bring us shocks.
And that's where we'll have to leave it. Thank you very much, Michael Grubb, University College London.
Thought-provoking stuff. Well, we are this week talking about fracking, and we've tried to leave the partisan proponents for and against shale gas in their respective party conferences, and we're getting the scientists to do the talking away from all the squabbling. With us now is Jasmine Cooper. Jasmine's a research associate at the Sustainable Gas Institute at Imperial College and is going to shed a bit more light on some of the environmental but also the social consequences of fracking. Jasmine, first of all, we haven't considered yet the question of when we burn this gas, does it amount to the same outcome, which is it's still a climate change gas? Will it still lead to greenhouse gas emission changes in the atmosphere, whether it comes out of fracking or comes out of the North Sea from our existing gas fields?
Absolutely. As Andy said, shale gas is exactly the same as the natural gas we get from the North Sea. So when you burn it, you will get CO2 emitted. You also get methane emissions from the different stages of producing it as well. And
when we go through the process, as Michael just said, we've got to drill a lot of holes. Andy said, and you then shove stuff down under pressure into the ground in order to prop those holes, small holes, open. There's a lot of stuff going in. There's a lot of environmental impact there that is very visible. It's on land. It's near people's homes. Let's sort of drill down, excuse the pun, into each of those elements in turn. The environmental contamination in terms of what we put into the ground. Tell us about that. How much of a risk is that judged to be?
Well, it depends a lot on whether or not you'll get any seepage from the hydraulic fracturing into any local aquifers or any water bodies. We've had such little drilling activity, it'd be really difficult to actually try to put a number on whether or not there'll be any risk to water contamination.
Experiences in other countries, America?
There is some experience of maybe some migration of chemicals that was used in the fracturing fluid, as well as some migration of methane into some local water bodies as well. So potentially, yes, but it really depends on whether or not you have any water bodies near where you're drilling. So it goes down to a lot of surveying your area really well.
One of our listeners got in touch and said, well, how does this all get policed in terms of, is it self-reporting, or is there a regulator? Is there an oversight body? What sort of mechanism is in place to keep tabs on this, and also to predict, in the way you're saying, that this might or might not happen?
Well, in the UK, it's quite different to the US because things are regulated quite differently there. A lot of it's on the federal scales. In the UK, there's a lot more regulations and regulatory bodies. So big organisations like the Oil and Gas Authority, BEIS, Environment Agency, so they'd be able to regulate and police these different environmental aspects.
But you're saying that because we've done not very much of it, we have not very much experience of it, which makes it a bit chicken and egg. Do we have to do it, find out what can go wrong to work out what to police? Or is there already a framework for, if we do go down this path, this is how we're going to keep tabs on it?
Unfortunately, yes, because each shale gas well in each area that you do drill in, it'll be very different to one another. So you can't, it's not like an IKEA set where you can just follow the instructions. So unfortunately, you will have to learn as you go along. You can look at the US because they do have the massive scale of shale gas exploration there. So you can look at to see if there's any lessons you can learn from them on what to do and what to not do.
Okay. And in terms of that pollution argument, how significant do we judge that to be? Because that is something that people are extremely vocal about, with groundwater contamination, spread of what gets put down into the wells and so on. How much of a threat do we regard that as?
Based on what's happened in the US, it's not necessarily contamination from the hydraulic fracturing and then migrations. That would be the biggest threat. It would be more of the flowback fluid that's produced. So
what you put down the well coming back out the well?
What comes back up, yeah. Because in addition to the chemicals that's in the fracturing fluid, you also get any chemicals and minerals that's within the rock that would have dissolved.
That you wash
out? That's washed out and comes back up.
And what can happen to it?
In the UK, it was proposed that any flowback fluid that was produced, that it would be sent to wastewater treatment plants to get treated. But there are some issues because quite a few of the chemicals that get used in the fracturing fluid, so lots of like surfactants that are used to control the viscosity, but also chemicals that can come up from the rock. There's some like radioactive materials, they can also come up. They're not things wastewater treatment plants are designed to treat.
Not normally, no.
No, just like concerns about how they're going to handle that.
But what sort of volumes are we talking about? Just briefly, I mean, what amount of material might the wastewater comprise? Are we talking thousands of gallons, millions of gallons, litres? How many?
Per well, it depends on the scale, but you're looking at hundreds of thousands of cubic meters of water.
So huge. This is a significant issue.
Yeah.
Fair enough. Let's consider then the sort of social aspects, because we've looked at the sort of geological and the environmental and why people therefore might object to them. What about the whole social thing? How receptive are people really to this? Are people saying, yeah, okay, I can see there's an energy crisis, we need to do our bit, it's fine, or are people saying absolutely not over my dead body?
I think it's an interesting time because obviously we are in a bit of an energy crisis, so that might shift people more towards being more accepting of it. But from an environmental side and also from a community side, if you live near a site where they're going to drill, you may not like the idea of earthquakes that you didn't sign up for when you first moved to where you live, and also the increase in traffic and just the general industrialization of what are normally quite rural communities.
The Prime Minister was talking to BBC Radio Lancashire recently. They were pressing her on the question of this whole issue of what they are dubbing local consent. Have a listen to this.
Let's talk about local consent right now. What does local consent look like, Prime Minister?
Well, the Energy Secretary will be laying out in more detail exactly what that looks like, but it does mean making sure there is local support for going ahead. And I can assure
it sounds like you don't know.
What is local consent, Jasmine?
So local consent would be having the support and backing of the local communities so that they are on board with the development of shale gas activity in their area and are actively in favour of the development, and there's no local opposition from both the local community but also the local authorities.
Because I think other members of the Conservative Party have said, well, people who live near, say, the new nuclear power station that's been endorsed on the southeast coast in England should get free electricity. So is this a sweetener? Are we saying, OK, people can get free gas if you live near a fracking site? I mean, where's this going to end?
I'm not entirely sure because it depends on where you're drilling the gas and what the gas infrastructure is like. So potentially they could get like highly subsidised gas if that's something the operator wants to do. But at the same time, I think it's quite tricky to try to like incentivise communities by saying, oh, we'll give you free energy, because to a certain extent that's a bit like trying to bribe them.
It sounds like coercion almost, doesn't it? I mean, are you comfortable with the question of fracking? And if you were living in this area, would you say, look, knowing what I know, I'm an expert in this area, I'm quite comfortable with it going ahead, please do? Or would you actually object?
From a scientific perspective, I find it really interesting. But if I had to live near a site where they were going to drill shale gas, I might be a bit anxious.
Nuclear power station?
Less anxious.
Less anxious. It's interesting, isn't it? Because a lot of people say they would much rather live near a coal-fired power station than a nuclear power station. But wait, what the coal-fired station chucks up the chimney is more radioactive than because of what's coming out of the ground are being burned by the thousands of ton load. Jasmine, thanks very much. That's Jasmine Cooper. She's from Imperial College. That's where we have to leave it for this week. We have to say thank you very much to our guests, who were Andy Woods, Michael Grubb and Jasmine Cooper, who helped us to wade through the fracking controversy. Hopefully we've cleared up one or two things for you at home. Next time on the programme, we're looking at long COVID. What have we now learned about this phenomenon that affects up to 1 in 5 people who catch the new coronavirus? If you'd like to share your experiences, do tell. It's chris@thenakedscientist.com. The Naked Scientist comes to you from the University of Cambridge's Institute of Continuing Education. It's supported by Rolls-Royce. I'm Chris Smith. Thank you for listening. And until next time, goodbye.